to do so. So, without any further ado, I'm now going to move on to Stephen Wright's question. And Stephen Wright has asked us, how can he connect a PIR motion sensor and a 12 key keypad to a 12 keypad to a PIC and program them using Logicator so that they could be incorporated into an alarm project. So, what I'm going to first do is just have a quick look at the two devices that is after. The first one is a PIR module, or a passive infrared sensor. And what that does is it detects the movement of heat, and this module is 3-wire interface. Oh, there we go, back in focus. Worried for a minute. There's a 3-wire interface on this. You've got your ground wire, your positive volts, and also there's the alarm out signal. So it's really easy to use. So we're going to be talking about that. And then the other item that we have is the 12-button keypad. Again, this is a pre-made module. You've got your connections on it, and I'm going to go through how to use those. So if we start with the PIR module. Sorry. Right, what we've got on the PIR module is something that requires a positive connection, that's on the red wire, a negative connection, don't ask me why, but that's on the brown wire, and then there is an output, and that's on the black wire. And the output on this device is something called a open collector output. And what that means is, inside the PIR, we've got a transistor, and the collector of that is fed through to the output there. What this therefore means is that in order to get anything sensible out of here, we need to put a pull-up resistor up to the positive supply. Any value will do. 10K is fine for the purposes of pretty much most circuits. What will then happen is when the PIR module senses some movement, the transistor will switch on. That's normally set in a high state. That pulls that down to 0 volts, and we go from a high state into a low state, and that's what we're trying to detect. And it'll be in that low state for about 3 or 4 seconds. So that then needs to go into our PIC microcontroller. And we're looking then for a change. So either we can do that as a interrupt, or we can do that as a just constantly checking the state. So that's the PIR section sorted out. Now I'm going to look at the keypad, and on the keypad I'm going to just start with what would happen if we had a single switch, and then we'll go on to how we use the full keys. So on a single key, that's the key there, we connect that to positive volts, and we're going to pull that down to 0 volts, and then we're going to feed that into the PIC microcontroller. So normally, when this switch is open, the state of the PIC will be in a low state because it's pulled down by this resistor. When we close the switch, we connect that up to the voltage, and then we can see that it's gone from 0 to 1 when the switch is pressed. So that's the simple circuit for one switch. Now, because we've got 12 keys on the keypad, we've got to do something slightly more complicated than that. So if we start over here, we've got the keypad, and that's the one that we've just shown you. It's got its 12 buttons on it. Now these are arranged into 4 rows, 3 columns in a grid format. And that's exactly how they're connected together. So if we take a look at this row of switches, one wire on each of these is connected together, and then the other wire is connected across, and each of these across wires is connected, and each of these in a row is connected. So it's basically it's in a matrix formation. Now the pin connections on the bottom of the connector here are slightly odd in the sequence that they go through in, but this is obviously due to the internal wiring. So pin 1 corresponds to this middle column, and pin 2 corresponds to the top row, and so on. But I've put the pins there. So in order to use this, what we need to do is the first step is we're going to take pin 3 high. So this wire, this goes into a high state. I'm going to leave the other two in a open state. So we've got plus faults on here, and if any of these switches are pressed, then they will connect through to one of these 4 wires, a high state. So what we do, take that line pin 3 high, and then we read pins 4, 6, 7 and 2, and if any of those are pressed, then we know in the case of pin 4 that the start button's pressed, 6 will be the 7 key, 7 will be the 4 key, and 2 will be the 1 key. So basically it's the corresponding key to each of those. The next stage is to take pin 1 high, disconnect these two, and then we do the same thing, we read those states. If 4 is in a high state, then we know it's 0, 6, 7 and 2 corresponding to 8, 5 and 2. And then finally we take pin 5 high, leaving the other 2 low, and we read those pins again, and this time they correspond to the end set. Now, in order to do this, we do need a pull-down resistor on the input pins here, and the pin that's not being used needs to be left in a floating state. So I'm just going to just move that out of the way a moment. And what I shall do is I'll just draw one connection rather than the entire keypad. So this is the circuit if we were doing a single switch. If we're going to do the keypad, what we need to be able to do is have some means of switching the power. Now it may be, if you've got a microcontroller where you can do bidirectional input-output, by that I mean you can set it as an output and then swap it to an input. Not all of them do, then you can bypass this transistor. But this allows us to leave it in the pins that we don't need in a floating state. So we've got the switch there, and then what we're going to do on that, we're going to connect that down to a pull-down resistor, and we're going to feed that into the PIC. So this is basically, when we were looking at the keypad earlier, this is one of the column wires, and this is one of the row wires, and we duplicate that circuit. That section would duplicate obviously 3 times, and then the wires into the processor would be 4 times. So that's just one of those switches shown there. So hopefully, Stephen, that's answered your question.